So we've all been sold this incredible dream, right? That we'll have this powerful AI living right in our pockets, ready to help us out at any second. But let's be honest, for a lot of us, the reality has been less futuristic assistant and more pocket hand warmer. Okay, let's get into why that is. You totally know the feeling. You're trying out some amazing new AI feature, maybe generating an image or something, and just minutes later, your phone is getting crazy hot, and that little battery icon is just plummeting. So what's really going on inside that little supercomputer in your hand? Well, a team of researchers from EPFL, that's the Swiss Federal Institute of Technology, decided they were going to play detective and get to the bottom of it. They set up this whole investigation to find the exact culprit behind all that heat and battery drain when running these advanced AI models on a regular smartphone. To solve the mystery, they had to do it right. First, they needed to set up the experiment, carefully picking their tools and, of course, lining up the suspects. And here is the crime scene. A totally modern OnePlus 13R smartphone, and this thing is packed with a powerful Snapdragon 8 Gen 2 chipset. It's got all the right tools for the job. A super fast multi-core CPU, the phone's main brain, a really capable Adreno GPU for graphics, and even a special dedicated AI chip called a Hexagon NPU. It's literally designed for these kinds of tasks. And here are our suspects. The researchers tested a few different AI models, the kind that can understand both pictures and words, from a big one, Lava 7B, to smaller ones made for phones. They also looked at the different software frameworks that run them. You can think of a framework as the engine that makes the AI actually go. And while all this was running, they monitored everything: how fast it was, how much power it was drawing, the temperature, and which chips were actually doing the work. Okay, so the stage is set. It's time to run the AI and see what the data tells us. And the very first clues started popping up when they looked at which parts of the phone's brain were actually being used. And this is where things get really, really interesting. In pretty much every test, the phone's main processor, the CPU, was just completely maxed out. We're talking 600 to 800% utilization. That is nuts. It means like 6 to 8 of its cores were firing on all cylinders. But then you look at the GPU, the chip that's literally built for this kind of heavy parallel work, and it was just sitting there, doing absolutely nothing, 0%. This right here, this is what's known as a CPU bottleneck. It's like having a whole construction crew ready to build a house, but you make one person do all the digging and the mixing and the bricklaying, while the expert carpenter and electrician just stand around and watch. It's just incredibly inefficient. So, and this is the key takeaway, this isn't a hardware problem. The phone has all the right parts. It's a software management problem. So what happens when one of these frameworks finally gets its act together and uses the right tool for the job? And wow, look at this. It's like night and day. In this test with the MLC-IMP framework, the GPU suddenly leaps into action, running at nearly 100% capacity. And check out the CPU. It's barely breaking a sweat, just kind of cruising along at around 100%. Meaning only one core is really active. The work was properly handed off to the specialist. Okay, so we've found our culprit. We know there's a bottleneck. But what does that actually mean for you, the person holding the phone? Let's talk about the real-world impact. In those tests where only the CPU was working, the phone's internal temperature hit a staggering 95 degrees Celsius. Yeah, that's 203 degrees Fahrenheit. We are talking just 5 degrees short of the boiling point of water. That's not just inefficient, it's physically uncomfortable to hold, and it's definitely not good for the long-term health of your phone. This chart just puts it all into perspective, doesn't it? Look at the CPU-only approach on the left. It's chugging over 10 watts of power to generate that insane 95-degree heat. But the GPU-assisted approach on the right, it was just sipping power, only 1.3 watts, and the temperature stayed at a much, much cooler 60 degrees. That is almost 10 times less power for a way cooler phone. So what does that huge power difference mean for your battery life? Well, the researchers did the math. With a pretty moderate workload, like 1 AI request per minute, the inefficient CPU-only phone would be dead in about 8 hours. The efficient GPU-assisted phone, it would last for almost 2 full days. Now, the really good news here is that because we know exactly what the problem is, there's a super clear path to fixing it. This isn't about waiting for better phones. It's about using the ones we already have way smarter. So let's just be crystal clear on this. The problem isn't that these awesome AI models are too big or too powerful for our phones. Not at all.
The problem is that the software frameworks are just failing to use the specialized hardware that's already in there, just sitting idle.
And the researchers laid out a perfect 4-step plan for developers. Number 1, offload to the GPU. I mean, this is the most obvious one, right? Let the expert do the heavy lifting. 2, activate the NPU. That's the dedicated AI chip that was asleep during all of the tests. Waking that up would be a huge boost. 3, use memory smarter. This just means reducing how much data has to get moved around, which saves a ton of power. And 4, overlap tasks. Basically run things in parallel so the whole experience feels faster and more responsive.
It all comes down to this. Just like the researchers said themselves, the choices developers make in the software can literally make or break the entire experience. A simple decision in the code can double the speed and cut power use in half, or do the exact opposite. It is that critical. So the next time your phone starts feeling like a hot potato when you're using an AI app, you'll know why. It's not a hardware problem. The supercomputer is already in your hand. It's just waiting for the software to finally catch up and unlock what it can really do.